Passenger planes today are comfortable and reliable, but could they fly faster? The latest engineering developments suggest we could speed planes up several times over, creating the true aircraft of the future.
From the shape of the plane to the environmental impact and economic viability, a European research project is studying in cooperation with Japan all aspects of passenger flight at several times the speed of sound.
The objective of a high-speed plane compared to planes we know today is reducing journey times, aiming to travel between Europe and Japan, for example, in around 3 hours.
Planes this fast will need new technologies of propulsion, new materials and completely new designs, developed by research and industrial partners from Europe and Japan.
You can imagine other shapes, but they'll have a lot in common. You always need these steep angles, a very aerodynamic design, because otherwise the drag just gets too high and you won't get enough thrust from your propulsion system to accelerate the vehicle.
Scale models are placed inside this 60-metre-long tunnel. This is where the extreme air pressure occurring in a hypersonic flight can be accurately generated.
In this wind tunnel, we can generate extraordinary high-speed airflow so we can simulate the re-entry of vehicles like the Space Shuttle Orbiter, or, what's interesting now, the flight of hypersonic vehicles at Mach 8 at 30-kilometre altitude.
The experiment is ready to go. Precise instruments will collect aerodynamic measurements in a fraction of a second.
But how will passengers feel flying at those speeds?
They wouldn't feel that much difference with respect to classical aircraft. Only the time aspect will be different. We're talking about acceleration times in the order of 20 to 30 minutes, but you can still have relaxed and enjoy the acceleration and see that you cross the sonic barrier and going even beyond that.
Most of the concepts place passengers beside the fuel tanks that would occupy a large part of the plane. Among other fuel options, researchers are considering liquid hydrogen. It doesn't produce CO2 and can be used as a coolant.
We need to develop a propulsion system to be operated from takeoff to Mach 5. Flying at Mach 5 needs a very hot structure for the engine. And our solution is to reduce the temperature by cooling the hot air by using the very cold fuel.
In another wind tunnel, researchers test special ceramics that can withstand extreme temperatures. These materials can protect the leading edges of a hypersonic plane that will be heated by air friction to thousands of degrees Celsius.
The objective is to keep the hot part narrow, so that the heat load to the passengers would remain as small as during the normal flight.
Wie in heutigen Transportflugzeugen mitfliegen können.
So, when can we book a ticket?
The timescale that we've given ourselves to produce a commercial plane is 2040 to 2050, but it depends on technical developments. Bye.